At the end of this topic, you should be able to understand the terminology related to queuing model, understand the nature and scope of queuing system, use the Kendall notation for queuing system, and determine the various parameters for a single server queue system. So what is a queue or waiting line? We experience the queue or waiting line at every places in our social life. It may be the ATM that we are visiting, mall or banks or cinema theaters or bus stops. Everywhere we have to wait in a queue to get the service. But this service or waiting lines are not limited to the human beings. So there could be some products waiting to get dispatched, or in older days when there were telephone exchange were operated by the humans, so call has to wait to get connected. So it was a waiting line for calls, or even in banks when you deposit the check is waiting for getting cleared from one bank to other bank. There could be aeroplane which is waiting for getting the clearance from the ground for landing, and there are certainly queues or waiting lines for the products to be get processed on a certain machine. So waiting lines are inherent part of the world. So queuing system, let us try to understand more about this queuing system and why do we need to study this queuing system. So what are the components of a queuing system? So queuing system have one service station. So there could be one or many service stations as per the requirement, and there will be some customers who are getting the services at these service stations, which is associated with certain time. So every service will require certain time, and it will have a certain rate, which may be the some determined time or which may be a random time. So which is denoted by mu. So mu is your service rate. Now there are customers who are arriving in the system at a various rates, so which may be equal interval, or they may arrive in random, and which is determined or which is usually denoted by this term as an lambda. As more and more customers arrive in a system, they create the queue, and these queues have a certain length. So number of customers waiting in a queue is your queue length. Also, customers have to wait in a line or in a queue, and that time is denoted by the waiting time. As customers get the service, they depart from the service station. Now there are other terms like LS, that is the average number of customers waiting in a system. Right now we need to understand that the number of customers in a queue are different than number of customer in a system. So number of customer in a system are number of customers in a queue plus number of customers getting the service. Similarly, the total time spent by the customer in a system is more than the time they spend in a queue. So customer is waiting some time in queue plus some time in getting the service, and that is equal to the total average time the customer spends in a system. Now there may be question in your mind, why do we need to study this queuing system? What is the purpose of studying this queuing system? So let us try to understand this. There are two costs associated with queuing system. One cost is very obvious, and that we require certain amount of money to provide the service, to set up a service station and to provide the service to the customer. If we have limited number of service stations, then there will be limited number of customers. If we increase the number of service stations, we will have more and more customers, but that will also increase the cost of service stations. Also, if we have very limited number of service stations, people or customers may not come to you because they have to wait a lot, and so they will find the different services. So you have to come up with certain a midway where you have optimum number of service stations and optimum number of customers, because if you have very limited service stations, then you will lose the customer and there will be loss to you. If you have a very large amount of service stations, that will increase your cost and again you may have certain loss. So to decide the level of service you provide, you must study the queuing system. Queuing system can be completely described by 1. The input, that is arrival pattern. Secondly, the service mechanism or service pattern. Third, the queue discipline. And fourth, customer behavior. So let us see what is an input or arrival pattern. So there is a service station and there is a queue and there are certain customers who arrive in a system and which is denoted by a certain rate known as lambda. Now the rate by which customer arrive may be a fixed one or it may be random. Now if it is the customer arriving at ATM center, you cannot predict and it is having a random arrival or some probabilistic arrival. But if you are considering a machine where parts are coming for processing at certain interval, fixed interval, then you can predict the behavior of the customer. But in most cases, they come randomly. The input described the way in which the customer arrive and join the system. Generally, customers arrive in more or less random manner and which is not possible to make a prediction. Thus, the arrival pattern can be described in terms of probability and in terms of inter-arrival time. So this is a very important thing, inter-arrival times, that is the time between two successive arrivals. And usually we convert it into arrival rate and which is denoted by lambda. So this is a very important parameter for the queuing system. A service mechanism or service pattern. Now this service pattern means the arrangement of service facility to serve the customer. If we have some infinite number of servers, then all the customers will be served instantaneously and there will not be any queue, but which is not an economical thing, and there will be certainly always some finite number of servers and customer may have to wait because they will not get any instantaneous services. Now if number of servers are finite and we have to serve the customer in specific order. Now every customer may take some constant time or it may vary randomly depending on the services he required. This particular distribution of service time is usually denoted by the exponential distribution and which is denoted by this mu as a rate of service, that is the mean service rate. The queue discipline, it is the rule according to which the customers are selected for the service when queues are formed. The most common disciplines are, the one is first come first serve. So whenever you visit the ATM center, the one who is leading the queue will get the service. So whoever is coming first, he is getting the service first. There could be some situations where you get the last in first out. Now imagine that there is an go down and you are putting certain boxes, certain products. Now the one you put in last will get lifted first, so this becomes an last in first out kind of an service. And there could be some instances where the service is provided in a random order or there is some priority. Now imagine the case of an hospital where if there is an emergency which is taken on the priority. Next is the customer behavior. Now customer may arrive in bulk. Imagine that there is some movie, famous movie which is getting released and lot of customers are coming to buy the movie ticket. There could be situation where if there are a number of parallel service stations and one find that other queue have less number of customers, so he may try to jump from one queue to other queue. This behavior is called as an jockeying. There could be situations when you find that there are already lot of people waiting in a line to get the service, so better I don't join this queue, and this behavior is called as an bulking. And in some situations it may happen that by looking at the queue only you decided not to join the queue, and this particular behavior is called as an rangering. We generally denote the queuing system with the help of Kendall notation. There are 6 parameters which define a queuing system. The first is the arrival distribution. What is the way in which these customers arrive, whether it is a probabilistic distribution or whether it is a fixed interval. Next is the what is the service time distribution. Again, whether it is a probabilistic distribution or whether it is a fixed time. How many number of service stations are available? Then what is the service discipline, whether it is first in first out, last in first out or random order. What is the maximum number of customers allowed in a system? It may be some finite value or it may be some infinite value. And what is the size of an source population, whether it is a finite value or infinite value. Let us see few examples to understand this system length as a finite or infinite. If you are coming to a railway station, some infinite number of people can join the queue and there is no restriction on how many people join the queue, and that is why we call that the maximum number of customers in a system are infinite. But there could be certain systems where you cut off the line after specific number of customers and you allow only finite number of customers in your system, then that becomes the system with finite number of customers. Similarly, the size of source population. Again, there could be some infinite number of people from infinite source can come to a railway station, because anyone can go to railway station for getting the services. But there will be some finite number of customers going to a specific bank because the number of customers are limited. Let us try to understand this Kendall notation system with the help of single server queue model. In single server queue model, we assume that the arrival distribution is Markovian arrival, or which is also called as an Poisson distribution, and which is denoted by this M. Again, there is an exponential distribution for the service time, which is denoted by this letter M. There is a one number of service station, so we denote it by 1. The queuing discipline followed is first in, first serve. The maximum number of customer in system allowed are infinite, and size of source population is also infinite. Let us solve one example to understand this queuing system in more detail. Assume that you are in a bank. Customer arrive at a banking counter at an average of 2 minutes, which follows a Poisson distribution. The counter clerk serves about 45 customers per hour. So this is the information given to us, and we have to find out certain values. Before we find out certain values, there are two most important things that we need to measure. The one is the arrival rate. What is the arrival rate? Now it is given that customers are coming to bank at average by 2 minutes. So in a 60 minutes, how many customers are coming? So there are 30 number of customers coming per hour. Similarly, the service rate is given directly, which is nothing but the 45 customers per hour. So these are the two important things that we should be knowing. The first one is arrival rate, lambda, that is 30 customers per hour, and service rate, mu, that is 45 customers per hour. Now with these two values, let us try to figure out some more important things. Now we will put these two things in our memory. What is the utilization factor of an system? What is the probability that customer have to wait? And what is the probability that system will be busy at a given time? Now all these three questions looks to be different, but they have a same answer. So what is the utilization factor of a system is very similar to the what is the probability that customer have to wait, and is very similar to the what is the probability that system will be busy at a given time. And the answer to all these three questions is given by lambda by mu. So you need to just remember this formula. Let us put values in this and you will get utilization factor for this system as 0.67. So 67% of the time the system will be busy. The same thing is that the probability that the system will be busy is 67% of time. Now we will put this value in our memory to evaluate the further parameters. What is the probability of having 0 customer in a system? What is the probability that customer does not have to wait? And the percentage of time arrival can walk in straight without having to wait. Again, these three questions are different, but they have a same meaning and same answer. By this formula, you can calculate the P0 value. So what is P0 value? P0 value means that is the probability of having 0 customers in the system, and that is given by the 1 minus this utilization factor that we have derived earlier. So putting the value here, you will get the answer as 33. So what is the meaning of this 33? That the percentage of time arrival can walk in straight without having to wait. So there is a 33% possibility that customer will not have to wait, but straight away if he goes to counter he will get the service. It is the same value that the probability that customer don't have to wait, and it is the same value that there will not be any customer in the system. What is the probability of having 8 customer in the system, or what is the probability of having 12 number of customer in the system, or any n number of customer in the system? The formula is P, you can consider it to be n, Pn is equal to phi, which is nothing but this utilization factor, raised to n in bracket 1 minus phi, bracket closed. Now if you want that what is the probability of having 8 customers in a system, you need to put 8 value over here, and if you put the rest of the values you will get the answer. So there is the probability that 8 number of customers will be in a system is given by this figure. Similar value can be calculated for the any number of customers. What is the length of a system? How many customers are present in the system at a given time? Both things represent one and the same. Now this value is given by this particular formula. You need to remember this formula. So if I put all these values, I get answer as 2 customers. So these are the total number of customers present in the system. Now when I say present in the system, there may be some customers waiting in line and there may be some customers who are getting service. What is the length of queue? How many customers are present in the queue at a given time and how many customers are waiting in a queue? All these 3 questions represent the same thing, that is how many customers are waiting to get the service, and you can calculate this value with the help of this formula. If you put all the values, you will get the answer. Now you can notice over that the number of customers waiting in a queue is 1. In earlier question we have seen that number of customers present in the system was 2. So number of customers waiting in a queue will always be less than total number of customers in that system. For how much time customer has to wait in the queue? Average time spent by the customer in queue. Both these represents only one value and that is given by this formula. So this is the total time customer spends in a queue, and this particular value comes out to be 2.68 minute. Similarly, how much time customer spend in a system? Average time spent by customer in a system is given by this formula and the value is 4 minutes. Now you must have noticed that this time, that is the time spent by a customer in a system, is more than time he has to wait in a queue. Now there is a different type of question. There is a complaint from the customers that they have to wait for a long duration. The authorities are willing to install one more counter in that bank if customer has to spend more than 5 minutes in the bank. Right? What should be the arrival rate at which that will justify the installation of a second counter? Now this is the application of an queuing system. Why we are studying the queuing system? To take the such a decisions whether to go for enhanced service or not. Now note that second counter will be installed if customer has to spend more than 5 minutes in a bank. What is the interpretation of this statement? What is the meaning of this statement? Try to think about it. So pause the video and just think about it. I hope that you must have given some thought to this question. Now it is said that a second counter will be installed if customer has to spend more than 5 minutes in bank. So the most important thing is time spent by customer in a bank. That is the time spent by a customer in a system which is given by this figure WS. If it exceeds the 5 minutes, then only the second counter will be installed. So I will write it down in this way. I will convert this 5 minutes into hour. So I can say that second counter will be installed if my total time spent by a customer in a system is exceeding these many hours. Now I will put this WS value in the formula which we have seen earlier. We know the value of mu, that is the service rate, and we can calculate the lambda, which is asked to calculate. So the value of lambda is given as 33 customers per hour. Now, earlier we were having this figure that customer arrive at rate of 30 customers per hour. If this rate is increased to 33 hours, then we will install the second counter. This is the meaning of this total question. Thank you.